Okay, so now that you've already seen the lesson on gas laws, we're going to move into the practice problems. So let me go ahead and flick over there real quick. Okay, so let's start off. I will give you a second to work these out. Pause it, and now we'll go. So, temperature calculations must be done using the Kelvin temperature scale, because it begins where there is zero or no kinetic energy. Increasing temperature results in an increase in volume. Okay, these are directly related to each other. Decreasing volume results in a blank in pressure. Since these are inversely related, this will be an increase in pressure. Lastly, decreasing temperature results in a decrease in pressure, because again, these are directly related to each other. Now, calculation problems here. A gas sample filling a 4-liter container. So 4 liters, as you read these, I recommend you identify what you have here. A 4-liter at 2 atmospheres pressure, so we have volume and we have pressure. These are the same samples, so we'll say that's V1 and P1. Would have what pressure? So what pressure? I need to know what is P2 when this gas sample is transferred to a 1-liter container at a constant temperature. So 1 liter, we're looking at V2. So since we know it's P1 V1 is P2 V2, when you plug these in, you'll get 2 atmospheres times 4 liters is equal to P2 V2. If I'm solving for P2, we'll divide that V2 down. So we will divide by V2, 1.00 liters, and we find that is 8.00 atmospheres as our new pressure. Under what set of conditions might the pressure of a gas be decreased when heated? So since we know P1 V1 over T1 is P2 V2 over T2, so we're saying that this is heated, so temperature is going to go up, so we would expect that pressure should also go up. However, the way that we can offset this increase in temperature is with a greater change to volume. So the only way that we can do this is if we have a very large volume increase. Okay, since these are inversely proportional, right? A large volume increase results in a pressure decrease. As long as the volume increase is large enough, it offsets the temperature increase. Determine the pressure of a gas sample that is heated from 0 Celsius at 55 kilopascals to 50 Celsius in a rigid gas tank. So we want to know what is the pressure, so P2 is what? When a gas sample is heated from 0 to 50, so this has to be T1 and T2. So it's 0 Celsius at 55 kilopascals. So related to T1 will be kilopascals, that is P1. Now before we work this problem, we have to remember all temperatures must be in kelvins. So 0 Celsius becomes 273 Kelvin. 50 Celsius becomes 323 kelvins. Now we'll set the problem up. P1 over T1 is P2 over T2. We can plug in the numbers, and our P1, 55 kilopascals, divided by my T1, 273 kelvins, is equal to the unknown P2 divided by the T2, 323 kelvins. To solve the problem, I can just cross multiply. 323 times 55 divide 273. When I do that math, here I'll go ahead and work it out with you here. We're taking 323, multiplying across up to 55, and then dividing 273, and that gives us 65.07, which when rounded is just going to be 65, because we have only 2 significant digits here. P2 is 65 kilopascals. Lastly, a certain gas at STP, which means a temperature of 273 Kelvin and a pressure of 1 atm, fills a balloon to 500 milliliters. So this is our volume. If we connect that all three of these are in the same sample, it's V1, P1, and T1. If the balloon is placed in a pressurized chamber at 5 atmospheres, so new pressure, P2, and at 373 Kelvin, so T2, what will the new volume be? V2 is what? So again, we think it's P1 V1 over T1 is equal to P2 V2 over T2. We'll plug in the values we know. We know that our initial pressure, 1 atmospheres, so it's 1 atm, times that volume, 500 milliliters, divided by our T1. In this case, standard temperature and pressure would give you 273 Kelvin. And that's related to our P2 V2. So P2 was 5 atmospheres. The V2 is an unknown, so we'll just write that as V2. And that is divided by the T2, 373 Kelvin. So to do this math, we will once again cross multiply. It'll be 373 times 1 times 500, divide 273, and divide 5. So in doing the math, let's go ahead and work this one out. It was going to be 373 times 1 times 500. Now divide out 273 and divide 5. It gives us 136.63, or rounded 137. The unit of volume has to be the same, so it's 137 milliliters.